All right, this is a video over two more problems from the review. I was asked to do number 22 and 25 was one of the ones we didn't get to in class. So if we look at number 22, this is the rolling two dice. One is white and one is gray. So we can distinguish between the two of them. And notice that there are 36 total possibilities for the way that we could have those dice land. So that's going to be our denominator most of the time, unless we're doing, say, a conditional probability. But let's go over and see what we have. So it says, find the probability that we have a greater than 3 on white. So that means our white could be a 4, 5, or 6. Okay. Or we have an even on gray. So that would be gray, 2, 4, and 6. Okay. So remember, or can be either or. So let's go through and we'll use pink to highlight this first part. Make that a little thinner. Use the thinner pink. So greater than 3 on white. Okay. So that would be this group is 3 or 4. This group is 5 and this group is 6. So all of these, that is 6, 6, and 6. That's 18 of those out of 36 are greater than 3 on white. Then remember, with an or, we add, so plus, and then we're going to do the probability of even on gray. Okay, so even grays would be this row because that has a gray 2. And we have this row, which has gray 4. And this row, which has gray as 6. Again, notice that is 18 out of 36. But because there is overlap, so notice these ones right here that I'm kind of putting a mark on, these were counted twice because they were counted in the pink group and in the blue group. So minus the probability that we were both of those things, or an and probability, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. We double counted 9 of our items. So if we add and subtract across the top, that'd be 36 minus 9. So that's going to be 27 out of 36. We can reduce that by 9 on top and bottom. So that's going to be 3 out of 4. So there's a 3 out of 4 chance that I'm going to get either greater than 3 on white or even on gray. Now that's helpful because we actually were able to answer the and probability as part of this, because this is the same setup. It's greater than 3 on white and even on gray, but now we're actually asking for the and. The and are those 9 items out of the 36 that were in both pink and blue groups. And if we reduce that, that's a 1 out of 4 chance. Okay. All right, so let's look at sum is greater than or equal to 8. So I'm going to erase some of my marks so we can start with a clean slate. And let's do purple, just different color. Okay, so sum is greater than or equal to 8. So remember, the sum is how the dice add up. So like 1 and 6 is 7. 2 and 6 is 8. 3 and 5 is 8. Remember, those go in a diagonal. So all the ones that sum to 8 are in this diagonal. But they said greater than or equal to 8. So equal to 8 would be this diagonal. Then we have our 9s. These all add to 9. 10, 11, and 12. So notice everything from this diagonal over, those all are sums bigger than or equal to 8. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 out of the 36, which we reduce that by 3. That's going to be 5 out of 12. Okay. And then for my last one, I believe that's the last one on 22. We're going to be doing the sum is not divisible by 4. Okay, so we're looking for things that are not divisible by 4. Oops, won't let me erase. Hang on. There we go. Okay, so one thing you could do is when you have a not problem, you could do, since it's probability, we can do 1 minus the probability that the sum is divisible by 4. Or we can just go ahead and count up what all is not divisible by 4. So the sum is divisible by 4 would be 4, 8, and 12. So if we look for just those are the complement, we could just take that away from 1, which is the total probability of all 36 items happening. So let's see, sum of 4 is this diagonal. So there's 1, 2, 3 items. This is a sum of 5, sum of 6, sum of 7, sum of 8 is this diagonal. 9, 10, 11, and 12. So notice I can either count all the things that are already here that are not marked out. Those would be just doing the actual probability. Or I can add up how many things I did mark out, and that would be this complement part. So 1, 2, 3, 4, 5, 6, 7, 8, 9 items were divisible by 4. So if we make this 36 over 36 to make it a common denominator, notice that would be 27 out of 36, or 3/4. So 3/4 of the items in our big chart here are not divisible by 4. Okay. All right. And then I was asked to do 25 since we didn't get to that one in class. So let's look at that. It says, are your finances, buying habits, medical records, and phone call really private? A real concern for many adults is that computers and the internet are reducing privacy. A survey conducted by Peter D. Hart Research Associates for the Shell poll was reported in USA Today. According to the survey, 39% of adults are concerned that employers are monitoring their phone calls. Use the binomial distribution formula. So notice it's telling us to use the formula to calculate the probability of the following. Round all answers to 3 decimal places. Notice this one, you can't use the table for the binomial distribution because it's not a multiple of 5%. So this is our probability of success is 0.39. That is that they are concerned about them being monitored. We'll just put concerned. Probability of failure would be that they're not concerned. So that'd be Q. So remember 1 minus 0.39. Let's see, what does that come out to? 0.61. So that's the complement, or not concerned. Okay. And then how many people did we survey? Let's look. So they don't tell us in the big paragraph, but they do here. Out of 4 adults. So we're doing a trial of 4. And we want to say that none, which means 0 successes. So none are concerned. So remember, for the formula, that would be, so I'm going to put part A here. That would be 4 people choose 0. And then it's the probability of success to the number of successes we were looking for, which is 0, times the probability of failure to the probability of how many people would be, or to the exponent of how many people would have failed. So remember, that's just subtracting the total minus this R. So that would be 4. Okay. So for that one, let me make sure I'm actually sharing calculator. Do full screen share. There we go. So my calculator should be showing up now. Now I don't have the C button on this this calculator. This is clear, not the CR that y'all have for probability. So I'm gonna have to use the factorial version of the formula. So if you're doing the factorial version, you do 4 factorial, and then we divide that by, and I usually put it in a parentheses, 4 minus 0, which is still 4 factorial, times 0 factorial, because you have the R factorial as well. And then we close that parentheses and we hit enter. So this is a 1. Then we times it by 0.392. There's my exponent button, to the 0, sorry. That's also 1. And then we times it by the 0.61 to the 4th. So this would be approximately they said 3 decimal places, so 0.138. So if they randomly select 4 adults to ask these questions for, that's their sample size, the probability that none of them are concerned with that probability of success being 39% is actually about 13.8% out of our sample of 4. Out of the 4 adults, again, all are concerned. So that would be an R of 4. So that's everybody's concerned. Okay, so for part B, we would have 4 choose 4. And that would be 0.39 to the 4th, because this time all 4 were concerned and nobody was not concerned. So that would be to the 0. Okay, so I'm going to do my formula again. So 4 factorial divided by parentheses 4 minus 4 is 0 factorial. This ends up being the same answer as the other one for the the choose formula. Because anytime you choose 0 items or you choose all of the items. There's only one way to do that. And then we times that by the 0.39 to the 4th. And then times by the 0.61 to the 0, which is a 1 as well. So this would be 0.023. Now notice that is less. This is only about 2.3% of that chance of happening. And that makes sense because if the likelihood of concern is even is less than 40%, it's 39% of people are concerned about that, then we're more likely to sample 4 people and get nobody being worried versus sampling 4 people and having all 4 of them being worried. It's just not very likely with this low probability of being concerned or success that we're going to see all 4 of them be that way. And then the last one for this part 25 was out of all 4 adults again, exactly 2 are concerned. So 4 choose 2 this time. So N equals 4, R is 2 is the success. And that would be 0.39 to the 2 and 0.61 to the 2 because it's half and half. Okay. So we're going to do 4 factorial because again, you can use your 4 choose 2 formula divided by parentheses. 4 minus 2 is 2 factorial. And then we times that by the R factorial. And then we get that equals 4. And then we times that by, actually it equals 6, sorry. Times that by 0.39 to the 2nd. And times that again by 0.61 to the 2nd. So that is 0.3395. So that would actually round up to 340. So 0.340. So about a 34% chance. So that was the most likely because that's the closest. I mean, 2 people is still not exactly what I would expect here since this is almost a 40-60 split, but we're having a higher probability of this actually being what we would see than the other 2 situations because this is closer to a 50-50 split than an all or nothing kind of approach. So that is how you use the formula. Remember, if you are doing number 26, you can use the table for that one. When we say hint, use the table because it has a percent that is, remember, a multiple of 5. So that all shows up in that binomial distribution table. Okay, I hope this was helpful.